go function composition here. This is lesson 3.6. So we're going to talk about the sum of two functions, the difference, the product, quotient. All right, and then later on we'll get into composition, which I'll show you guys in a minute. All right, so nothing new here. It's just kind of just adding two like terms here if they are like terms. And if you notice, you have your first function is f of x. You have your second function, which is g of x. And now I'm going to add and find a sum. So I'm going to take my function f of x and I'm going to add it to g of x here. So really this is the square root of x minus 1 plus the square root of 4 minus x. And there's nothing I can add here, right? These are not like terms. Right? If this is the square root of x minus 1 plus another square root of x minus 1, then I could add coefficients here. But these are not like terms here, okay? And then I'm going to find the domain of each one of these, right? And what is my domain of each one of these? So if we look here, you have the domain of f intersects with the domain of g. All right, so let's think about this for a second. So the domain of f here, right? So if we look at these individually, the domain of f, right? So my x values can't be less than 0, so it can't be negative. So I could have 1 would work, right? 1 minus 1 is 0, that would work. 2, 3, 1.5, anything from 1 to infinity here. The domain of 4 minus x here, right? So again, 4 would work here. And be careful because if I do 4, can I do 5? 5 wouldn't work, so because I don't have 4 minus 5. So it's actually going to be everything less than 4. Okay, so if you're looking at the domains of both of these, so now you have to take into consideration the domain of both of them here. So the domain of 1 is 1 from 1 to infinity. All right, so this is from 1. So domain of the g of x is 1 to infinity. Domain of f of x, g of x, sorry, is from 4 to negative infinity, or negative infinity to 4. So what you want is the intersection of both of these. So the domain of f of x plus g of x is from 1 to 4. Okay, so we're going to do something similar for the next one. Okay, so again, the difference of f of x and minus g of x, so nothing difference here. So f of x minus g of x. So this is, again, the square root of x minus 1 minus square root of 4 minus x. And again, these are not like terms. Like terms would have been x minus 1 plus the square root of x minus 1, and then that would give me 2 radical x minus 1, right? Or if there was a 3 here, and a 2 here, then that would give me 5 root x minus 1, right? But they're different. They're different radicals, so they're not the same. So there's nothing else I could do for these two, right? So that's all I can do. And again, the domain's going to work the same exact way. All right, so I'll look at this one graphically. Square root of x minus 1 starts here and goes this way, right? So your domain starts at 1 all the way to infinity. And if you look at this graph here, 4 minus x is really negative x plus 4, so it starts at 4, and there's a reflection, and that goes this way. So your domain here is from negative infinity all the way to 4. Right, so if you're looking at them graphically. So again, my f of x minus g of x is going to be the same exact thing. Nothing changes there. And the domain is going to be the same properties, right? So I'm still looking at, f of x starts at 1, goes to infinity. G of x starts, ends at negative 4, goes to negative infinity. So this is the intersection. Right, this is the intersection, which is represented by that symbol, right, the upside down U. Okay, and so again, my domain is just 1, comma 4. All right, now we got the product. So here we have f of x times g of x. And we have the square root of x minus 1 times the square root of 4 minus x. And we can actually multiply these, right? This is just going to be x minus 1 times 4 minus x here. And you can simplify all this. and you get, if you distribute, you get 4x minus x squared minus 4 plus x. So if I continue this up top here and I simplify this, I'll put this in standard form. I got negative x squared plus 5x and minus 4. All right, so that's the product. And again, the domain is going to be the same exact thing, right? So I'm looking at the domain of them individually. So I'm looking at, right, so the domain is, right, the product is the intersection of both. So the domain of f of x is, again, 1 to infinity. The domain of g of x, again, is from negative infinity to 4. So the domain here, again, is going to be just from 1 to 4. All right, and then lastly, the quotient here is just going to be f of x divided by g of x. And that's just going to be the square root of x minus 1 over the square root of 4 minus x. All right, and we're going to go from here. So here, going back to our properties, we can't have square root in my denominator, so I'm going to rationalize my denominator here. And this will give me my numerator, which is going to be x minus 1 times 4 minus x, which I'm going to steal from the other problem that we did, which is negative x squared plus 5x minus 4, and all over 4 minus x. Okay, and again, I'm going to do my domain here, and this domain is going to be a little different. Okay, so I'm still going to use the intersection of both, and we said f of x, again, the domain was 1 to infinity. G of x is going to be negative infinity to 4, and I want that, but I'm having a little issue here with 4. Right, so if I plug in 4 in for x, then I'm going to get 4 minus 4, which is 0. And I can't have 0 in my denominator. So I do want to include all the values between 1 and 4, but I include 1. But when I get to 4, I don't want to include 4. I can include 3.999999 or whatever, so I'm not going to include 4 in this domain because it's making my denominator equal to 0. If that wasn't the case, then great, then I would include it. But since that 4 in here makes this 4 minus 4 equals 0, my denominator, I can't include that. So we have to restrict that one. We have to restrict the 4 from the domain here as well. All right, let's try a couple more examples. So here we have the sum again, f of x plus g of x. So I'm going to write right here. So I got x squared minus 3x plus 4, right? That's f of x plus g of x, which is 1 minus 5x squared. And all I'm going to do now is just combine like terms. I got 1x squared minus 5x squared, which is negative 4x squared. Yeah, negative 3x doesn't combine with anything. And then plus 4, which is just plus 4. All right, and then if I look at the domain for all these, okay, so x squared minus 3x is just a parabola, so the domain of f of x is negative infinity to positive infinity, right? This is my U-shape, goes on forever to the left. And the domain for g of x is also another parabola, which is just negative infinity to positive infinity, which no domain restrictions here. So the domain for this one is just the intersection of both of these, which in this case is just negative infinity to positive infinity. All right, let's do the next one. So here we got the difference. So be careful with the difference, right? So I got an x squared minus 3x plus 4, and then minus, and be careful here, right? Because when I subtract, make sure you subtract. You're subtracting, if it's more than one term, then you're subtracting the quantity. And I'm subtracting 1 minus 5x squared. So make sure I'm subtracting both these numbers here. So really this is x squared minus 3x plus 4 minus 1, and then plus 5x squared. And then I could go ahead and combine my terms. I have 6x squared, right? 1x squared, 5x squared, 6x squared, minus 3x, and then plus 3. And again, the domain is going to be the same thing here, right? The intersection of both of these is negative infinity, positive infinity. No worries there, right? So there's no fractions you have to worry about. when we get to the quotients, when we get to the quotient in a few steps, we'll have to worry about the denominator, but let's get there first. All right, next one's the product. So we got x squared minus 3x plus 4 and times 1 minus 5x squared. All right, so now we got to do a little FOILing here, or distributing. We got x times 1, x squared times 1 is x squared, minus 5x to the fourth. Okay, that's done. Then I'll do negative 3x times 1, negative 3x, plus 15x cubed, and one more, 4 times 1, plus 4, 4 times negative 5, negative 20x squared. All right, and then we're going to combine some like terms here. And what we got? So I'm going to start with my highest. So I got negative 5x to the fourth. I have two terms with x squared. I'm sorry, before x squared, I'm going to do x cubed. I got one term with x cubed, so plus 15x cubed. Again, I got two terms with x squared, so minus 19x squared. Then I got minus 3x, and then a plus 4. All right, so my domain here again is going to be negative infinity to positive infinity. No restrictions here. Nice the intersection of both domains. All good. All right, last one. Got my quotient here. And the quotient is the one I'm going to be careful for with my domain, right? So let's go right here. Be careful with domain. Because now I'm going to create a fraction here. So I got x squared minus 3x plus 4 all over 1 minus 5x squared. All right. So in the future, we're going to try to factor this out if we can, and maybe we'll be able to, maybe not. So there's nothing else I can simplify here, and we'll get into more simplifying these later on. But again, I want to say my domain, so this is my final answer as a quotient. But my domain, I want to say is negative infinity to infinity, but that can't work because there's going to be a value in here that's going to make this 0. And every x value is not going to work, so I can't just use negative infinity to positive infinity. So the question becomes, is when does my denominator, so when does 1 minus 5x squared, when will that equal 0? All right, so I'm going to do a little math here. So I'm going to do 1 equals, I'll bring over this 5x squared divided by 5 divided by 5, and I got x squared equals 1 over 5. And then I'm initiating the square root, so plus or minus. And now I got x squared equals, or I'm sorry, I got x equals 1 over the square root of 5, plus or minus. I'm going to rationalize this, which is equal to plus or minus square root of 5 over 5. So when x is equal to plus or minus root 5 over 5, that implies that your denominator is going to equal 0, and that is not allowed. So my domain can be everything but these numbers. So how do I write this? So if I think about this on a number line, right here is negative infinity. Somewhere around here is a negative root 5 over 5. Then I get, there's a 0 somewhere. Then there's a positive root 5 over 5. And then this goes on to positive infinity. Okay, so my domain is, I'm allowed to equal everything from negative infinity all the way up to this number here. So far, my domain is negative infinity all the way up to negative root 5 over 5. And stop. I'm going to jump over, which is my union, and I'm going to go on the other side of root 5 over 5, so negative root 5 over 5. So then I'm going to jump over here, and I'm going to start, and I'm going to allow it to equal everything up to, again, positive root 5 over 5. I'm going to jump over again, is my another union, and I'm going to go on the right side of this, so positive root 5 over 5, all the way, and then that's going to take all the way to infinity. So that's going to be my domain for this function. So it's everything except for those numbers. But since you created 1, 2, 3 intervals, you have to write them as 1, 2, 3 intervals for your domain as well. All right, let's see what else we got here. So same idea happens for example 3, finding out, if you're dividing here, and 4, and then we get to compositions. Okay, so for time's sake, let's, maybe I won't do all of them, but you know what, let's do one because this has absolute values. This is a little different. So f of g of x, so I got square root of x over x minus 3, the absolute value of x minus 3. Okay, so I can't simplify this any further, and there's nothing else I can do here. There is only one value for x where I'll get this, I'll get the absolute value of x minus 3 equal to 0, and that's only going to happen at x equals 3. So in this case, your domain, right, x cannot equal 3 here for your domain, because if I put 3 in there, then I'm going to get, if I put 3 in there, then I'm going to get 3 minus 3, and that's going to give me 0, and which is just 0, right? And then it cannot have 0 in my denominator. So x cannot equal 3 there. Okay, so that's gone. So this is my function. There's nothing else I can simplify. And the domain here, again, so let me think about the domain for each one of these. Oops, sorry. So domain of the domain of f of x is from 0 to infinity, and the domain for the absolute value of x minus 3, remember the absolute value of x minus 3 is just going to be something that looks like that, 3 is to the right, so your domain is negative infinity to positive infinity. So you want the intersection here. So if I'm going with my intersection here, this function starts at 0 and goes all the way to infinity. So it would start at 0 and go all the way to infinity. Right? So I'm going to exclude all the negative infinities, right? So I'm going to exclude all those. I'm not going to have all those. All right, but I also have to exclude another number. I also have to exclude the number 3, right? Number 3 cannot be in there. So I'm going to go from 0 all the way to 3. Then I'm going to jump over 3 and then go from 3 to infinity. Okay, so here we go. So my domain is from 0 to 3, not including 3. Jump over to 3, it's my union. Start on the other side of 3, so 3, 2, and then go into infinity. And parentheses. All right, let's do 4's very similar. And you could definitely do 4 and 5 on your own, 4A and 4B. I'll let you guys try and tackle those on your own. Look at your class notes for those. And let's get to function composition. Right? And then here's another one. Right? So we no longer have where we're multiplying or dividing. Okay, what we're going to do is we're going to take the composition of functions. So we're going to embed one function into another function. Okay, so g of x is going to be embedded into f of x. So let me show you what that looks like. Okay, so we're going to call this, so when we see this, right, this notation, two notations we'll use, one or the other, and we read this as f of g of x. Right, so f of g of x. All right, so which really just means I'm going to first find g of 2, and then I'm going to take that answer and then put that answer into my function f of x. So what's g of 2? G of 2 is 7 minus 3 times 2. All right, so here's my g of x function. I'm plugging in 2 for x, and I'm going to get 7 minus 6, which is just equal to 1. Okay, so g of 2 is equal to 1. So now I'm going to take that 1, right, and now I'm going to find f of 1 here. And f of 1 is 2 times x squared, which now is 1 minus 1. And then this is just going to be 2 times 1 minus 1, or 2 minus 1, which is 1. So f of g of 2 is equal to 1. Right? And you could do it the other way around, right? I did f of g of 2, and I could do g of f of 2. And it doesn't necessarily mean it's going to be the same exact thing, so be careful here. Okay, so you could get 2 different answers here, but that's the idea behind one of those. And you could try it on your own and see what you get. So I'll do it as you're doing this. We already said, well, I'm going to find f of 2, so this is 2 times 2 squared minus 1, which is equal to 2 times 4 minus 1, which is equal to 8 minus 1, which is 7. So f of 2 is 7. Then I'm going to go in, take the 7, and I'm going to use g of 7, right? That's going to be the new x I use. And g of 7 is 7 minus 3 times 7, which is 7 minus 21, which is equal to negative 14. So g of 7 is negative 14. So also correct this as g of f of 2 is equal to negative 14. All right, so you can do this with numbers, or you can do this with variables. All right, so here's the variable piece you can see. For any given x, right, I'm just going to take g of x and embed into my function f of x. So I'm going to start out with f of x. So f of g of x looks like this. I'm going to start with f, my bigger function. So here it is. So it's 2 times x squared minus 1. But in here, I'm going to put my g of x function. So I'm not putting just a one number in here. I'm going to put my g of x function. So my function of g of x is 7 minus 3x. So 7 minus 3x is going in for x in the f of x function. And then that's it. And then you just simplify all this. All right, so this is 2 times, remember, this is 7 minus 3x, 7 minus 3x, and then minus 1. And you can play around with that, and it's going to be 49 minus 42x, and then plus 9x squared, and minus 1. Right, distribute the 2 here, you get 98 minus 84x plus 18x squared, and then minus 1. And then lastly, just write this in standard form, so 18x squared minus 84x plus 97, and this is f of g of x. Right, so that's plugging in the g of x function into your f of x function. Right, we do this the other way. This time I'm going to plug in f of x into my g of x function. So I'm going to start with my g of x function, which is 7 minus 3 times x. And instead of x, this is where I plug in f of x, which is 2x squared minus 1. Right? This one's going to work out a little nicer. So 7 minus, distribute the 3, 6x squared, distribute 3, plus 3. And in standard form, negative 6x squared plus 10. So g of f of x is equal to negative 6x squared plus 10. All right. Not bad, right? This is actually not bad. Just a lot of computation here. All right. So for the next problem we're going to look at, I'm going to come back here for a second and just recognize that your input, for f, it becomes the output to g, and then you get your final output. So we're going to do the same thing here, but this time we're going to do, I'm going to give f of x as a relation. Right, so here's f of x as a relation, so just coordinates. And we're going to try to make sense of all this here. And then you have g of x here as well. Right, so these are just coordinates and not, a relation, not just the actual functions. All right, so the first one. It says f of g of 0, right? Or I gotta write this as f of g of 0. Okay, so piece by piece. So f and g of 0, so I'm going to pull this to the side for a second. What is g of 0? I'm going to go to my function g. When g is 0, when x is 0, g of 0 is 4. So that 4 is going to go in here. Okay, then I go back and say, okay, well, what is f of 4? Well, when f of 4 is 6. So f of 4 is 6. And that's it. Right, so f of g of negative 1, for part B, I'm going to write this as f of g negative 1. Right, so hopefully you see that notation easier. I'm going to erase these lines here for a second, just to clean this up a little bit. Alright, so I'm going to find g of negative 1. So use g right here. So my input is g of negative 1, which is going to give me an output of 2. I'll just write that a little different, right? So focusing on g of negative 1. Right, g of negative 1 gives me an output of 2. So the next piece here is I'm going to do f. Now I know that g of negative 1 is 2, so now I'm going to look at f of 2. So I'm going to go to my f function. So when x is 2 in my function f of x, the y value is negative 5. And that's it. All right, let's do one more. Hopefully this question is going to arise here. So let me think about g of 2 for a second. All right, so I'm going to erase this lines here to clean this up. G of 2, so g of 2, okay, so g of 2. So I'm inputting 2, I'm getting an output of negative 1. Okay, so now I have f of g of 2, which we just said is negative 1. Okay, so now I'm going to go to my function, f, and find negative 1. We got 0, 2, 4, 0. So negative 1, negative 1 does not exist, right? Does not exist. Right, does not exist there. I don't see it there. So because it's not there, then we're just going to say f of negative 1 is undefined. Right, it's not defined in this function. So sometimes that happens as well. Okay, a couple more. And again, this lesson will probably do over 2 days. You could go as much, you could get as far as you get. Let's see what else we got here. All right, so this is going to be similar. Okay, so h of g of x. So h of g of x. So g of x is going into h of x. So I'm going to start with 3 and then x to the negative first power. And you can write this as 3 over x if you want to, right? That's the same thing. So I'm going to do that. I guess it doesn't matter, but you could do it either way. Right? And then I'm going to substitute in g of x in here. And so g of x goes in here, which is 2x minus 1. So 2x minus 1. So this is 3 times the quantity of 2x minus 1 to the negative first power. Or you could write 3 over 2x minus 1, which is the same thing. Right? So h of g of x is equal to this. Right? And then the other one, this one's going to be g of h of x. Right? So g of h of x. So this time I'm going to start with my g function, so 2 times x minus 1. And this time h of x goes in there. And we say h of x is 3x to negative 1. And that's just going to be 6x to negative 1 minus 1, or 6 over x minus 1, which, you could leave it like that. or you get a common denominator, which is going to be 6 minus x over x. If you want to use it as common denominator, either one. Okay, and this one's not asking for your domains here or anything, so you don't have to worry about that part. All right, and then h of x. So h of x. Okay, so you're embedding h of x into its own function. Cool. All right, so we'll start with h of x, which is 3x to negative 1. And I'm going to embed, again, h of x in there, which is 3x to negative 1. All right, so cool. So you can simplify this, and this, again, if you distribute the negative 1, you can get 3 to the negative 1, and then x to the first, right, if you distribute the 1. So this is going to be 3x over 3, or just x. All right, and that's it. So there's some function composition with some of those. And the next one will be something similar. You're going to have to do a little bit of algebraic manipulation here. So in this example 7, we didn't do the domains here, but I'm gonna go back to some domains here for example 8 just to make sure we have those down pat. So I'm gonna find f of g of x. So I'm always gonna start with the outside function, which is f. So I have 1 over x minus 1. And instead of x, this is where g of x goes, which is going to be 1 over x. So I have this, and I could try simplifying all this. So I don't have a fraction over fraction. So I'm going to simplify it. So I have 1 over, this is 1 over x minus, technically this is over 1, so my common denominator here is x. So it's going to be x over x. And then this just becomes 1 over 1 minus x over x. And then this is really just the same thing as saying 1 divided by, right? So this is my division sign, 1 minus x over x, which is the same thing as saying 1 times x over 1 minus x. Right? I'm going to keep, change, flip here. And then you're just left with 1 times x over 1 minus x, which is just x over 1 minus x, right? This is just me simplifying that fraction. Okay, cool. And there's a domain restriction here, right? So you notice that this 1 minus x cannot equal 0, right? Because your fraction can't equal 0 ever. So 1 does not equal 0 when x is equal to 1. So your domain is, x cannot equal 1. So for restrictions here, we have a domain restriction for f of g of x, but we have some domain restrictions for f of x as well. So if I go back to f of x here, what's the domain here? Well, this is everything, right? X in this one, x cannot equal 1 here. Right? So here it's saying x cannot equal 1. Oops, sorry. X, you don't want a 0 in your denominator. So it could be everything else besides 1. And for this one, your domain here is x cannot equal 0. Okay, so I'm thinking about this on a number line. So from negative infinity to positive infinity, we got some issues at 0, and we got some issues at 1. So we can't equal 0, we can't equal 1. Okay, so what's my domain? So I'm going to start from negative infinity, comma, all the way to 0, and stop. Jump over 0, union, start up again at 0, comma, all the way to 1, and stop. Jump over 1, union, start up at 1, start on the other side of 1 again, and then all the way to infinity. And that'll be my domain here. Right, so here's my simplified function. So this is f of g of x, and then with the domain of that right there. All right, cool. let's go with a word problem here, and maybe we'll stop the video here, and then I'll do the word problem in the next video, so it's not too long.